Hello everyone, welcome to my channel Chemistry is Fun. Today I have started the video Atomic Structure Part 4 NEET 2024. I am continuing with the topic Atomic Structure. Previous 3 videos I have discussed about the various important topics of this chapter. Today we will deal with quantum numbers. Now see, there are so many people in the world. If you meet somebody and you want to know where he lives, first of all, the person should say the country where he lives. He has to tell about the city where he is residing, then the area of the city where he lives, and finally the house number. So with all these 4 informations, you can find out the exact position of that person where he is residing. Similarly, if we want to locate a particular electron in an atom, we have a set of 4 identification numbers. These identification numbers are called as quantum numbers. So we can say that there is a set of 4 integers which are required to define an electron completely in an atom, and these set of 4 integers are known as quantum numbers. We will deal with them one by one. First is principal quantum number. It was given by Bohr. Principal quantum number, it was given by Bohr. It is denoted by the letter small n. I mentioned here, denoted by the letter small n. It gives or it tells about the size and energy of the shell. Electrons are revolving around the nucleus in some shells. So this quantum number tells about the size of that shell and the energy associated with that shell to which the electron belongs. Now this n can have many values starting from 1. So if we give them values, we have to start from 1. N can be 1, 2, 3, 4 up to infinity. 1, 2, 3, 4 up to infinity. At the same time, we can have some designation of the shells. Designation first, when n equal to 1, we name the shell as K. First shell, we name it as K. Second one, L, capital L. Now when we are designating with the letters, all the letters are, that is the alphabets, they are capital starting from K. So K, L, M, N, like that we can designate the shells respectively. One very important thing about this quantum number is that higher the value of n, greater is the distance of the shell from the nucleus. As means n value increases, means it is away from the nucleus. Okay, because we know in my previous video I have told R equal to n square by z into 0.529 angstrom. So R is directly proportional to n square. As n increases, the distance of the shell from the nucleus will also increase. Okay. So this one we can explain with the help of this formula. R equal to n square by z into 0.529. For this unit will be angstrom. So as the value of n increases, greater will be the distance of the shell from the nucleus. Next we have to see is azimuthal quantum number. It is denoted by small l. Azimuthal quantum number denoted by small l. Azimuthal quantum number was given by Sommerfeld. Azimuthal quantum number is also called as angular quantum number, given by Sommerfeld. This tells about the shape of any given orbital. Shape of a given orbital. It tells about the subshells, means there can be four types of subshells, S, P, D or F. Now the energies of the various subshells in the same shell will be in the order of S less than P, P is less than D, and D energy level is less than that of F subshell. So this what I have written, just it is the energy, order of energy. Energy is in the order of. This is for the same shell, means we have to take SPDF from the same shell. Okay. Now what can be the values for L? If you know the value of N, we can find out what the L values can be. Okay. So the value for L will be between 0 up to n minus 1. Starts from 0 up to n minus 1. So if n value is 4, we have to take up to 3. Means when n equal to 4, L will be 0, 1, 2, 3. So 0 to n minus 1. When L is 0, it means it is S subshell. When L is 1, it is P subshell. When L is 2, it is D subshell. When L is 3, it is F subshell. With the help of L, we can also find out orbital angular momentum of an electron. It's given by square root of L into L plus 1, because L value we can find out. When n is known, we can find out what is L, and we also know then what the subshell will be. So we can find out the orbital angular momentum of that electron. Square root of L into L plus 1 into h by 2 pi. Square root of L into L plus 1 into h by 2 pi. If value of L is 0, that is it is S subshell, then it will be a circular orbit. Whereas L is not equal to 0, any other value, then it takes the elliptical path. This is important. Next is magnetic quantum number, it's denoted by ml. Magnetic quantum number, ml. It tells about the orientation of the subshell, means how it will be oriented, means along any axis. It tells about the orientation. Its values will be from minus L to plus L. Minus L to plus L. Like when if L is 1, when L equal to 1, the values for M will be minus 1, 0, plus 1, means 3 values will be there. That is, there will be 3 orientations. 3 orientations. When L is 1, ML will be equal to minus 1, 0, plus 1. These 3 values are possible. So 3 values means 3 orientations. 3 orientations. If it is a P subshell, as I told you earlier, you see here, when L equal to 1, it is a P subshell. So when L equal to 1, the values for M can be minus 1, 0 and plus 1. So it should have 3 orientations. So here you see P subshell is having 3 orbitals. Similarly, D subshell will have 5 orbitals. F subshell has 7 orbitals. So these all are interrelated, you see. S orbital is spherically symmetrical and non-directional. This is somewhat we can say this, like this we can represent the S orbital. It is spherically symmetrical and non-directional. In case of 1s orbital, the electron cloud is maximum at the nucleus and decreases with the distance. In case of 1s orbital, the electron cloud is maximum at the nucleus and decreases with the distance. As the distance increases, it will be less. It will become less and less, the cloud. And the electron density at a particular distance will be uniform in all directions. Uniform in all directions. Now p orbitals have dumbbell shape. See, I have shown here. P orbitals have dumbbell shape and they are directional in nature. This is 2px along x-axis, this one. You see, I have drawn three axes, x, y and z. 2px is along x-axis. And this one is 2pz. 2pz is along z-axis. In this figure we can see. In the three axes x, y and z, 2pz will be along the z-axis. Out of the 5d orbitals, 4d orbitals have a double dumbbell shape like this. Double dumbbell. This is dxy. I have drawn all the three axes and this is dxy. Double dumbbell shape. Only dz square has a different shape. This 4 means dxy, dxz, dyz and dx square minus y square. These all are double dumbbell shape. Dz square has a different shape. The total number of orbitals present in the main energy level is given by n square. See, when n is equal to 1, for n equal to 1, we have 1s orbital. For n equal to 1, there is 1s. S orbital is there. So 1. 1 square is 1. For n equal to 2, we have 2s and 2p orbitals. 2p orbitals are 3 in number. Only one 2s orbital and 3 2p orbitals. So 1 plus 3, 4. So when you square these 2, we get 4. So we can say that the total number of orbitals present in the main energy level is n square. Okay, like that. Next will be when n equal to 3, it should be 9. 3 square 9. So there will be 3s, 3p and 3d. 3s is 1 in number, 3p is 3 in number. 1 plus 3, 4 and d will be 5. 5 plus 4, 9. So like that. Next we come across spin quantum number. Spin quantum number. It tells about the spin of the electron. Its values can be plus half and minus half. It tells about the spin. Plus means clockwise spinning. When the electrons are spinning in clockwise direction, we represent it with a plus. And minus signifies anti-clockwise spinning. Anti-clockwise spinning is minus. So this is the spin quantum number. So we have dealt with more or less all the numbers of this. From here we can understand how we are able to explain about the electron, where it is, means its position. Spin quantum number we denote by small s and it was given by Goldschmidt. Spin quantum number was given by Goldschmidt. There will be a spin angular momentum which is given by square root of s into s plus 1 into h by 2 pi. Square root of s into s plus 1 square root of, I am repeating again, square root of s into s plus 1 into h by 2 pi. Now total spin of an atom is given by n into half. Total spin of the atom is given by n into half, where n is number of unpaired electrons. Number of unpaired electrons. That gives the total spin. So I hope students, all of you could understand the topic I discussed today. Please subscribe to my channel. Thanks for watching my video. Please share the video with your friends. I'll be again making videos with the topics which are related to your studies. Please subscribe to the channel. Thanks for watching. Thank you.